Welcome to my channel. Today, we're going to look at how I did a permanent install of holiday lights on uh, my garage over here and also the window over here. Today, mainly we'll focus on this guy and basically the software that controls these and the hardware and the wiring and all that stuff to actually get them to sync using Wi-Fi. We're going to use NeoPixels and WLED software. So just let's look at the dimensions first. So this is my garage, and I'm planning to put the controller inside the garage because we want to protect it from the snow, rain, and the sun and stuff like that. So the idea was to put it in there and then send the wire that contains the data as well as the 5 volt to this end of the garage. So the LED lights start from this end of the garage, which you can't see in this picture, goes to this corner, goes up here, goes up to here. So that's around 12.8 meters. And then this controller over here has controller that is sitting on this side of the window, and the LED lights go from here to here to here. So this is 60 LEDs per meter WS2812B LEDs. So this is 5 meters of that, and this one is slightly more spaced out. So here we only have 30 LEDs per meter, but again, this is a longer length as compared to this guy. So let's look at the LED. The LED is WS2812, which operates at 5 volts, and it has been very popular among DIY, and this is also called as NeoPixels. Adafruit sells it, whole bunch of sellers sell it on AliExpress, Amazon, Banggood, and various locations. So the beauty of this LED is that each LED is individually addressable. That is, you can change the color of individual LEDs on a strip. So the controller is actually embedded in here, and that controls the red, green, and blue diodes that is in here. So this is actually pretty cool. That means that you can have a lot of animations once you start chaining them together. So I specifically like this particular seller. So they have a bunch of different varieties of LEDs that you can buy. So when you just look for WS2812B, there are 3 different kinds. So the first one is without any kind of protection, it's just the bare strip. The second one is IP65, so there's kind of like a silicone coating on top of the strip. And then the third type is they take this strip and put it inside a silicone tube. But again, that means that when you want to cut different lengths, then you're going to compromise the integrity. That is, you're going to cut through the silicone tube as well, and you have to seal it up. So in our case, I decided to use IP65 LEDs. These are great, and then you can easily cut them at different points that are these cut locations. And they also have adhesives that come on the back of these LEDs. You can get it at different densities. So you can go from all the way from 144 LEDs per meter. That's a lot of LEDs, all the way down to 30 LEDs. And we decided to go with 30 LEDs per meter. Again, you can choose the color of the strip. So we chose the white one. So white one with 30 LEDs per meter. So let's talk over the different components. So this is in my garage. So this is just a waterproof box that I bought off Amazon. I'm going to leave links of everything that I use in the description, so don't worry. You can just click over it and figure out what I used. So this box is just a waterproof box. So I just wanted to keep a choice that if I decided to put this box outside, it'll still be okay. So this is kind of like weatherproof, and I used some glands. These are called connector glands as well. So just to be like, safe. But anyway, so the main controller is probably only just this huge thing that is the 60 amp 5 volt DC power supply that takes 110 volt regular plug input. So basically, this can power a lot of LEDs. So it's always good to have a little bit of overhead. So right now, this is an overkill for the number of LEDs that I have currently, but that means that I don't have to buy multiple power sources in the future if I decided to make this more fancy, that is expand our number of LEDs. So this is just the starting of this project. So basically, let's see where this ends up. So basically, the 5 volt is supplied to the controller over here. In my case, this is an ESP8266 that runs the WLED software. We'll go over that later. But then the signal that comes out in this yellow wire, along with the 5 volt and ground, is sent to these LEDs using 18.3 AWG wires. So that's 5 volt data and ground. Because I'm using a level shifter here, I can probably use long length of these wires. The colors look perfectly fine, even if I use somewhere around 50 feet of these 18 AWG wires. So the idea was to put the controller inside the garage. So basically, I did not want to drill through our garage, that is compromise the integrity of the wall over there, and probably thread a wire through it, and it was just too daring for me to do that. So I just decided to go through the soffit. So soffit is something that is actually the underside of the roof, that is this tiny little overhang over here. So they already have these holes. So these holes help with regulating the humidity that is inside when it rains, and kind of like make sure that this doesn't get there is no condensation on inside the roof and all that. But again, so the idea was to then use a soffit, so it's easy to drill, and it already has a hole. So I just pick one of the holes and make it bigger and threaded the wire through it. And somehow it got into the attic of the garage. Put some plywood so that I can like rest on it and not, just break through the drywall, and then pull the wire from the hole that I just made, and then drilled a hole on the drywall to actually thread this wire into the garage. So it is much easy, less than 5 minutes. I was in and out, and then threaded the controller, and this is sitting inside the garage. So this is one way you can get some wires outside, and water getting in through here is actually very, very difficult. It can happen, but it's much better than drilling a hole on a vertical wall. So if you're going to do something like this is something that you can be aware of, that you can use these soffit to actually thread some wires, or you want to put some cameras and stuff like that, you can use this. Let's look at the controller. So this I developed a few years back for the McLighting project, but again, the idea is the same. So basically, we have the ESP8266. We have four N1, N2, N3, and 4 10 kilo ohms resistor. So these kind of make sure that it is kind of turned on. So that is what we want for this state of ESP8266. And then you probably want to have the power to actually reset this, as well as flash this. So this one extra resistor, 470 ohm, is used to actually pull this particular pin to ground, and that way you can program it. And this button actually resets the switch, that is reset the ESP8266. And then I have this contact point. So basically, if you want to use GPIO3, that is NeoPixel, you can send data using a different methodology using GPIO3. So then you would solder a bridge between the middle pad and GPIO3. But in our case, we just solder between GPIO2 and the middle pad. So this way, this gets connected to the signal wire over there. And basically we also have a resistor over here. We have a step up kind of like a level shifter chip over here. So the data that's sent from ESP to 66 is 3.3 volt, and then that is converted to 5 volt, and that is sent out. We also have a voltage regulator over here, which is HT733. Oh, there's a typo over here, and 1000 microfarad capacitor for ESP8266, and this one is primarily for helping with stabilizing the power that is supplied to the LEDs. Again, the links are going to be in the description, so you can just click on it and see how it is designed. So software-wise, I'm going to use WLED. It's a great software. Eric Cookie is a main developer on this project. He's done a great job with this. So I have personally tested certain features of this, and I use it on a daily basis. So that's why I have highlighted the ones that I mostly use. So it comes with apps for both Android and iOS, and MQTT to integrate with Home Assistant, as well as HTTP requests with the new versions of Home Assistant. We can do real-time data that can be sent for each LED, and it is able to interpret that and display it in a very great fashion. For again, it depends on number of LEDs that you have, and this is one feature that I use, is to synchronize multiple devices on the particular animation that it is doing. And what I use is some kind of automation on the chip, so you don't have to use Home Assistant to actually get certain schedules going. So there are macros that you can turn on and off at certain point of times once you set the time. And the beauty of this is it's open source, which means you can add things that you need. And I'm highlighting this. That's a bunch of examples in the user mod folder in this project. So I wanted to use a temperature sensor, so I made the modifications. So again, I'm going to leave the links in the description for the modification that I made. Again, there are multiple examples in there. You can use whatever suits you. I wanted to check the temperature of this box when I close it. So that's why I just broke out the different pins on the ESP8266 and was able to connect a BMP280. All I wanted was temperature. I don't need the humidity inside. So I just used the cheaper version of the temperature sensor, and basically compiled this WLED software with this, that it sends the temperature data every minute to the MQTT setting. That means that I have to set the MQTT on the ESP8266. So in terms of wiring, I would like to advise that if you were to repeat this, do power injection. That's what I'm doing here. So we have our 60 amp power supply over here that supplies 5 volt DC current that powers the ESP8266. The data from ESP8266 is sent to the LEDs. So the problem with these LEDs is, as a function of distance, because it is made up of copper wires, and copper wires do have resistance, you're going to have a voltage drop. And if you have a voltage drop, the LEDs at the end of these strip are not going to have a good representation of the color that it has to show. So then what you can instead do is make a connection to the power supply over here and use wires that are 18-2 gauge wire that can actually go all the way to the intersection point of two 5-meter LED strips, and that's how I'm injecting power at different points on the LEDs. So this is called power injection, so you can read up on that, and a bunch of people use it, and this is one of the advice that I was able to decipher from various projects or people who've done this kind of project. You can use any 18-2 wire. I just chose to use the cheapest one locally available, so I just went and got 18-2 thermostat wires and soldered it in to the beginning of the strip, all the way, jumped it to the intersection point of the first strip and the second strip, and also jumped from there from the second strip to the third strip. So you can also do this, and it is very important, and it does give very accurate colors even when you have long stretches of LED strips. Again, for mounting these LEDs, there are multiple options. So these are the thinner ones. So these are like U profiles. So you put the LED in there and then use these diffusers. And they provide you with different end connectors. They also provide you with clips and screws to actually install this. And these have this is a slightly different version where you can put the LEDs over here, which is at a 45-degree angle. So let's say if you want to hit the corners of a certain room or outside, then you can use these kind of LED strip mounting aluminum channels. And these are a little thicker ones, so if you don't have enough space for this guy, you can use these guys. But in our case, I chose to use these guys. So I have a bunch of these that I was able to easily put both the LED strip as well as the power injection cable. I just squeezed it in there. So let's look at the installation. So installation involves 2 steps. The first step is to actually drill 1/8" holes. You can use any kind of drill that you have, and then drive these clips with these screws that are provided 20 centimeters apart. So the next step would be actually to clip in the aluminum channels. So I'm going to show you how I'm doing that. So these just, click in. So these LED strips already come with very strong adhesive on the back, and these are good quality 3M kind of adhesive, and they are like very strong. I was very impressed with the stickability, and I don't know how long it's going to last in there, but let's see. So it's in there, and all you have to do is peel the sticker off, and then this thing is kind of very sticky, and then you can stick this on the LED channels, the aluminum channels. Once you have the aluminum channels, then you just press in these plastic diffusers. They kind of like diffuse the LED light, even though I use only like 10 or 20% of the intensity of the LEDs. these diffusers work great, and they are like press in, so you just start on one corner, press that in, and then squeeze all the way through the length of the LEDs. So in terms of software, you just go to LED preferences, and then you can change the number of LEDs. This is important. So basically, if you don't set the correct number of LEDs, your animations might be off. So you want to make sure that you have the correct number of LEDs, and it calculates how much power supply you would need to power through those LEDs. And you can also limit the power if you want to by enabling this particular check mark that's on this side. Once that is done, you want to set the direction of LED strips. Again, you go to LED preferences, go all the way to the bottom, and you can say reverse LED order and rotate 180. So basically what you can do is you can change the orientation of the animation. So since my LED strips on the window go from this direction to here, which is in the clockwise direction, but this guy goes in the anti-clockwise. So basically an animation would start on this end and end here, and the same thing would happen on this side. So that would not look great. So basically you invert one of these guys. So basically whatever animation happens, it looks synchronized and it looks really pretty. So this WLED gives an option to actually reverse it and reverse your animations to make it synchronized. And to set up MQTT, again, you go to sync interfaces in the settings, go all the way to the bottom. So you would click on enable MQTT, and then put in the broker's IP address, set in whatever is your MQTT's IP address. So this could be the integrated broker that comes with Home Assistant. By default, it uses the port 1833. You can also set up the username and password for this WLED. You can also set up the client ID, that is the name that it publishes to the broker when it connects, and also the different topics that it's going to subscribe to. Why you want MQTT is so that you can send the temperature data every minute to Home Assistant, so that way you can monitor the temperature of the controller box that is inside the garage. You can also use MQTT to send a lot of animation messages or messages to actually get everything synchronized. So if you send it to the group topic, all the WLEDs on your network are going to respond and would change the animation depending on what kind of messages you send. You can again click on this MQTT info and actually see what are the different kind of messages you can send. At last, I wanted to show you the synchronization as well as auto cycle. You click on the sync icon on the top. For preset auto cycle, you click on the favorites at the bottom corner. You can set a bunch of favorites, presets, and then you can just check mark on the beginning of the cycle that you want to start, and that's it. It'll then go through every animation for a certain amount of time, and then it's just like kind of like a light show. So all this is on the controller, so that is great, right? So you don't even have to like use a Home Assistant to actually do any of this. Everything is automatic, that is on the device, and even if there's no Wi-Fi connection during an intermittent time, it can still power through the animation that is going through, and then it is kind of independent. So at the end, I'm going to show you the different montage, and this is just the beginning. So once I get more and more confident about doing this work, I'm going to expand on this network of LEDs, and this is going to remain permanently on the house. Let's see. So enjoy, and come back next week for another video.